4.3 Differentiation rules for sinusoidal functions. So yesterday we worked with pretty basic rules. We learned that the derivative of sine of x is cosine of x, and we learned that the derivative of cosine of x is negative the sine of x. But what if we get more complicated sinusoidal functions like these? We need some more rules in order to do those, in order to find the derivative and use them in different applications. So here are some rules, and guess what? They're the exact same as the differentiation rules that we learned earlier in the semester. So we have the chain rule. The chain rule states that if you have a function that is built out of two differentiable functions, then dy over dx is equal to the derivative of the outside with respect to the inside times the derivative of the inside. This might not make a ton of sense all by itself, but let's say you had, I guess the point is, if you have a function y that is f of u, and u is another function, say g of x. So g of x is a function that's inside f of x. So you have f of g of x. Yes? Composite function. You have a chain rule. You take the derivative of the outer with respect to the inner, multiply it by the derivative of the inner. Okay. Next rule. The power of a function rule. It says, if g of x is differentiable, then the derivative of g of x to the power of n is equal to n times, square bracket here, right? N times g of x to the power of n minus 1 times the derivative of g of x. Again, maybe going back to general notation is more complicated than it needs to be since you know how to do these already. But here you have a function raised to a power. Again, we're going to take the derivative of the outer with respect to the inner and times it by the derivative of the inner. And then we have the product rule.
Isn't part of the function rule the chain rule we had earlier?
So maybe In the product rule, you have a function that is built, that is the product of two other functions. And then, so we can call them the product of f of x and g of x. And if we want to take the derivative of that, so f of x, g of x prime, this, again, this is just one function, but it's the product of two functions. Then what do? We take the derivative of the first function, we multiply it by the second function unchanged, and then we add the first function as is times the derivative of the second function. So there's our three basic rules. They apply to differentiating any functions, and they also apply to differentiating sinusoidal functions. So that's what we're working with today. Example 1. Chain rule. All right, we're going to find the derivative with respect to x of y equals the cosine of 3x, and there are just two examples, two pieces, two different problems here. So in the first one, what do we see? Okay, we see a function, really two functions. So we have the cosine of x, and we have 3x. So if we let y equal the cosine of x, except not the cosine of x, sorry, the cosine of u, and then we're going to let u be 3x. So now we have two functions. We have the function u inside the function y. So again, the chain rule says that to differentiate y with respect to x, all we need to do is differentiate y with respect to u and multiply it by u with respect to x. So here we go. We've got the derivative dy by dx, so taking the derivative of this guy. We're going to take first the derivative of y with respect to u. So that's just this first piece. Okay, the derivative of cosine of u is what? Excellent job. Negative the sine of u. And you know what? Maybe we'll do it, no, we'll do it like this. And now all we need to do is multiply it by, so that's this part right here. And now we need to take the derivative of u, which is just 3. So there's our two pieces. Multiply them together. We get negative 3 times the sine of u. But we're not done yet because we want the derivative of y with respect to x. So now we just need to sub in what u is. And we get negative 3 times the sine of 3x. So if you're looking for a faster way to do this, you can kind of see what happened is that this 3 ended up in front as a multiplier, and the derivative of cos was negative sine, and then the little piece here ended up staying the same. Let's see if that's a pattern that continues to emerge.
It doesn't make sense though, because
okay, we're going to do b over here. B is the function f of x equals 2 times the sine of pi times x. So again, we have a function, and we could think of it as, it looks like we're actually just going to use what we just found out from over here. But let's try to do it all by itself. So we have f of x, and we could make that like, if I wanted to keep this notation, maybe don't write anything yet. Okay, I'm going to let y be our first function with respect to u, and I'm going to let u be what we see here in place of the x. So we have y with respect to u and u with respect to x. So now if I take the derivative dy with respect to dx, I'm first going to take the derivative of this part, which is just going to be which is going to be 2 times the cosine of u times the derivative of this, which is just going to be pi. And that would give me 2 pi cosine u. Now I can sub back in. U is pi x, because I'm looking for the derivative of y. With respect to the derivative of x, I end up with 2 pi times the cosine of pi x. And if it's helpful for you, you can put a little bracket around those to remember that it's the cosine of that product. So from both of these, working it through, what did we find out? All we really need to do is take our the derivative of this piece, what we are taking the sine of, which in this case is pi. Pi is just a value, okay? It's not a variable, so don't get mixed up. We're just going to take pi, put it as a multiplier out front, and then take the derivative of sine, which is cosine. Okay, so you can actually go straight from here to f prime of x equals 2 times the derivative of this piece here, which is pi, times the derivative of what we have here. So sine of pi x, the derivative of that is just cos of pi x. Same thing over here. If we have the y is the cosine of 3x, we can get y prime by simply taking this 3, the derivative of this piece, which is 3, and multiplying it by the derivative of this whole thing, which is negative the sine of 3x, which would get us negative 3 times the sine of 3x. In example 2, we're using the power of a function rule. So in this case, we have an inner function and an outer function. The first one that we're doing is y equals cos x cubed. So now if you can remember, this thing is actually the cosine of x cubed. That might be helpful as we think about it. So we have two functions then. We have an inner function, cosine of x, and we have an outer function, x cubed. So if we're taking the derivative of this, dy by dx, we're taking the derivative of the outer function with respect to the inner function. Okay, maybe I'll use this notation first, and then I'll do it just using this. But here it's really easy to see that you have 3 times the cosine of x squared, and then we're going to multiply by the derivative of the inner, which is negative the sine of x. And we can reduce that to negative 3 sine x cosine x squared. Remember, this was just a sneaky notation to make it less cluttered when you're writing mathematical things, but you can't write this squared here because then it looks like the cosine of x squared, which it's not. Okay? Now again, you can convert to this and then do it. That was really a lot easier to think through, but if you get good at doing it from here, you can just right away say, okay, the derivative of this piece is 3 cos x squared, cos squared of x, and then you could take the derivative of the inner function, which is cosine of x. So the derivative is negative the sine of x, and then you could simplify that. Negative 3 sine x cos squared x. My brain finds this a whole lot easier to work with, but your call. B. It's a little bit longer. Y equals 2 times the sine cubed x minus 4 cos squared of x. So now we just have two separate pieces that we're going to use. So we're going to apply the power function rule to each of these pieces. And then I also see a negative symbol in here, so that tells me we're going to be using the difference rule as well. So to differentiate this first piece, ends up being 6 sine squared x times the derivative of the inner, which is sine x, which would be cos x. Then we have our second part for cos squared of x. The derivative of the outer with respect to the inner would be 8 times the cosine of x, and then the derivative of cosine of x is negative sine x. This reduces. The first thing I'm going to do is just put my two negative factors to make this thing positive. So I've got 6 sine squared x cos x plus 8 times sine x cos x. Just to be consistent, we generally write sine first as the factors of sine first. Which again doesn't really matter at all. And then I can factor bits and pieces out of this. So I see a common numerical factor of 2. I see a common sine x and a common cosine x, leaving me with 3 times the sine of x plus 4. And since we're in the world of trig, we're not really done yet, because you should recognize this, or you could possibly recognize that. That's a double angle formula, a double angle identity. So that piece actually reduces to the sine of 2x, and then this factor remains the same. Okay, quick note, what did we do? Here we had the power of a function rule. Power of a function. Then we had the difference. And then down below we had a double angle identity right here. Double angle identity. Example 3. Product rule. Product rule. Find each derivative with respect to t. Y equals t cubed times the cosine of t. So again, we have two functions here. We have t cubed and cos of t. So we could, rewrite the whole steps here. I'm not going to. I think this is pretty automatic for us right now. We've got dy by dx. We're going to take the derivative of the first function, which is 3t squared. Multiply it by the second function unchanged. Then we're going to add the first function unchanged times the derivative of the second function. Cos t, derivative is negative sine of t. And then we can simplify. First piece is simplified already. Just copy it down. Second piece ends up being negative t cubed sine of t. And now we can look for common factors again. So I have 2 factors of t here and 3 factors of t there, so I can pull out 2 factors of t, leaving us with 3 cos t minus t sine t. B. There are only 2 here. B is our last problem. H of t equals the sine of 4t times the cosine squared t. So again, if you want to rewrite this piece, you can. We're going to try to do it without. We're taking, we have a first function here and a second function here. The second function uses the power law, and the first function uses the chain rule. So here we go, bit by bit. We're going to take the, we're just going to copy down. I'm going to do it the other way this time, as it makes no difference really which way you do it. I'm going to just copy down the first one and take the derivative of the second one. So the derivative of the second one means taking the derivative of the outer with respect to the inner. That would be 2 times the cosine of t, and then times the derivative of the inner. The derivative of cosine of t is negative sine t. Okay, that's a big string of things, but it's all multiplication, so we can put it together, but I'm going to do the second part of this still. We need to add the second one unchanged times the derivative of the first one. The derivative of the first one says I can take 4 out front and multiply it by the derivative of that first, that outer or inner part, I guess, cosine of 4t, and then that's it. That part's done. So now we can simplify. Here we have 2, we have a negative factor, so we have negative 2 times the sine of 4t times the sine of t. I'm just going to put them all in brackets so it's easier not to mix them up. Times the cosine of t. Over here, we have 4 times the cosine of 4t times the cosine squared of t. And then we're looking for factors. We have a factor of cos t here and 2 factors of cos t here, and we have a factor of 2 in each. And because this factor is negative, I'm actually going to, or this term, I guess, is negative. I'm going to put this term second. So we're going to factor out 2. We're going to factor out cosine of t. Then I'm going to say what's left from this term here, which is going to be 2 times the cos of 4t times the cos of t. And we're subtracting this piece. We've already factored out the 2. And we factored out the cos of t. So we just have the sine of 4t times the sine of t. Close bracket. And again, you don't actually need any of these rounded brackets because it's all they're already all separated by multiplication. And yep, that looks good. So again, be careful. It's a bit tedious along the way. It might be easier for you to rewrite this as the cosine of t squared, and then you can clearly see that the derivative is the derivative of the outer with respect to the inner times the derivative of the inner, and then work it through carefully, pull out your common factor, and that's that. Power law, power rule, chain rule, product rule for differentiation applies to trig functions as well as polynomials, rational functions, etc. Practice problems come from page 231, numbers 1 through 15.